Okay, so once again, depending on the order that you watch these videos, you've probably already seen the one about how pages are laid out. Now remember, relations in a relational database are represented by one or more files. Each file consists of a collection of pages, and inside those pages are tuples. So that's what we wanted to talk about now. So here's a quick throwback to the page structures that we talked about last time. So we've got a directory that tells us whereabouts in the page these tuples are located, and we know how many tuples there are. There's a chunk of free space, and there's all these things up here. Now these things are actually just sequences of bytes, and we can work out how long each one is by taking a look at the starting point for the next tuple. Okay, so R2, or a starting point for the previous tuple, in fact, because these addresses, R2 is actually going to point to the low address, and R1 will point to the low address up here, so the span in between is the size of record 2. Alright, now of course these things are records and not tuples. Yes, they represent tuples, but they're actually just sequences of bytes. And we want to find out how we can interpret that byte sequence, and that's really what the tuple representation is all about. So, tables are defined by schemas. These identify what the attributes are in each tuple or in each record, and the information we've got here, the type information, part of it tells us how large the value is. So we know that an integer is a 4-byte value, a small int is a 2-byte value, a varchar is up to 20 characters, but the actual value could be anywhere from 0 characters if the person had an empty name, or could be all of 20 characters, and similarly the job can be any number of characters up to 10. Alright, so a schema defines what the tuples contain. What we've got is a bunch of bytes, and what we need to do is interpret them as values of certain types. Okay, so a tuple is a collection of attribute values, and a record is simply a sequence of bytes, and that's what we'll find in the page if we go looking for it. So this is what we're going to see in the page. This is how we want to view that information. And I didn't bother to check whether these zeros and ones actually corresponded to anything in here. So they may not if you go and check. But on the off chance that this happens to be the first 4 bytes, that's likely to be the contents of this first attribute. May not be. We'll see lots of different ways of representing tuples in a byte sequence as we go through this video. Alright, so at some point what's stored on the disk is just a byte sequence in a page. We get that page off the disk, that gives us the same byte sequence in memory, and then that has to be interpreted as a tuple. So we need to somehow work out what these values are based on the schema, which we know because we know what relation we're dealing with. And ultimately we've got a record, simply a byte sequence, and we've got a tuple, which is, if you like, a typed collection of values, attribute values. Alright, so in fact there are a number of places where the information that allows us to interpret those bytes might be stored. If we got a fixed size record, for example, all of the information that we need could be in the DBMS catalogue, because the catalogue will say what are the name is is important, I guess, but what's the type? That tells us how large the attribute is, and that's pretty much all we need. Once we've got the size, we can work out which part of the byte sequence corresponds to which attribute. So we don't actually need to store anything in the record. So the record is pure tuple data. Some of the information might be stored in the page directory. At the moment we're assuming that the page directory, if we go back to the first slide, the page directory is this, simply consists of offsets. So we know that R1 is a tuple whose byte sequence starts there, R2 is a tuple whose byte sequence starts there, and so on. So at this stage all we've got is an offset. Occasionally, if we wanted, and all of this stuff that I'm talking about here is possible ways that we could represent these things. It's not necessarily a way that a particular database represents them. Right, so it could be stored in the page directory. You might want to do that if you've got, well, in theory you could store the tuple structure as part of the directory, or you could replace those individual entries in the directory by something that gave a little bit more information about each tuple. Or you can store the information in the record. We'll see how we do that in a couple of slides' time. Or the information might be split between stuff in the schema and stuff in the record. So for fixed length records we can certainly deal with the tuple structure from the catalogue data. As soon as you've got variable length records, you have to store some information in the record or the page directory. So because variable length records have fields, maybe varchar 10, how long is the actual string? Well, the only place we can record that is something that relates directly to the record, either in the record itself or maybe in the page directory. And basically what we need to know is how big each of the variable length values is. Not the maximum size, but what is the actual size of the value. Alright, so we need to get records from the database. I think I may have changed the interface here a little bit. I think in some of the earlier slides I had a relation ID as part of the record ID, but let's assume that we've got them separately. So the relation, we've got an open relation, we want to get a record from that relation. The record ID tells us which page and whereabouts within the page, or at least the index of the directory to the page, so we can go to that directory entry and then go to the bytes. Alright, so we can extract those two components from the record ID. We do obviously use the page ID to extract a page from that relation, store it in a buffer, typically somewhere in the buffer pool, and then we're interested in getting the record itself. So we need to know whereabouts the record is located, given the buffer information, given the directory, and given the tuple ID. We can find the start address and possibly the size of the record, and then we can read that information, or we can return that information as a sequence of bytes. However, just having a byte sequence by itself doesn't really help us. We need to interpret that relative to the tuple structure for the relation. So we can call this get record. That'll give us a record structure. We need to convert that into a tuple, and we imagine that there's a make tuple function that takes a record, takes a relation, and gives us back a tuple structure that we can then use to access the individual attribute values. Alright, so once we've got a tuple, how do we extract the attribute values? Well, there's going to be typically a bunch of extraction functions called get blah blah blah, get type, and a field ID. So we've got a tuple. Let's say that we've got some examples down here. The first attribute is an integer. We've got a tuple stored in variable t, and we're interested in actually getting the value of that first field. So you can imagine that we've got a function, something like this, that will give us an integer value. And let's say the second attribute is a string. So we say we're interested in the second attribute in the tuple t, and I want to get a pointer to the string that value is. Alright, so if we've got fixed length records, so now what we're talking about is how do we actually implement things like get int field. To do that, we need to know information like this. Right, so the format of the records, here we're talking about fixed length records. So every record has exactly the same structure, exactly the same size. Each attribute is the same size in all the records. So in this case, the first attribute is 4 bytes, second attribute 20 bytes, regardless of how long the actual string is. So it'll be blank padded. Similarly, the job description is up to 10 bytes. In fact, we've changed from our definition. Got to watch that carefully. The original definition had varchar, so it wasn't a fixed length record. But if we'd actually written those name and job fields as char20 and char10 rather than varchar 20 and varchar 10, then we would have had a fixed length record. So the kind of information that we need to extract the attribute values is we need to know where does the attribute start. So this first attribute starts at offset 0 within the byte string that represents that contains the tuple data. So we can go and look at the first 4 bytes here. How do we know it's 4 bytes? 2 possible ways we could work that out. One is to also know what the type is, and knowing what the type is will give us the size. Alternatively, we could just look at the starting point of the next entry and say, all right, all of the bytes up to that point are part of the first attribute. Similarly, for the second attribute, we could say, all right, the characters start at offset 4 into the record, and they finish once we've reached position offset 24. So that would give us all of those bytes. And so on and so on. You might say, how do we know how long the last field is? Well, we can work that out by the starting point, or the starting offset, and the overall size of the record. If we're doing things like this and we're getting the information from the catalogue, it's a bit expensive to have to go to the catalogue all the time. Every time we've got a tuple, we've got to go and extract this information again. So typically this kind of information would be cached in a buffer, for example, and maybe you could mark that buffer as never to be removed from the buffer pool. Alright, for variable length records, well, there's a number of different ways that we could encode the information in the byte stream. One is to put a field length. So let's assume we're never having values larger than 256 bytes. We can have a single byte here which tells us how many bytes we need to look at to get the field. So here we know that there are 10 characters in the field, so we go and grab the next 10 bytes. 8 characters, grab the next 8 bytes, and 2 bytes for this final field. That's one way to do it. Another way to do it is sort of analogous to what C does with strings. It doesn't store a length of a string anywhere, it uses a terminating value. So we can have some value. It's an interesting thought to think what that value might be, given that all bytes are potentially valid, but if we can come up with a byte that represents end of previous field, we can simply put it at the end of each field, and as we scan through the field, we can discover that we've reached the end, and we may have a special terminator at the end of the record. And final possibility is to actually put the information at the start of the record and then have all the data afterwards. So we got the overall length of the overall length of the record, which includes all of this, including the header, is 34 bytes. The first field starts at offset 10. So imagine that each of these things is 2 bytes. That's 2 bytes. So we've got 5 things there. 5 times 2 bytes is 10 bytes. So that's the starting position for that field. The next field starts at byte 14, so we can work out from that this field is length 4, or possibly we can actually store the length here as well if we really wanted to. So given this information here, we can extract the individual components. All right. So what kind of types do we have to deal with? Well, there's a standard set of types. Integer is obvious, real numbers, floating point numbers. Dates and times are a database type that you don't find in programming languages. You can have fixed size numbers. You can have variable length character strings. And all of these things at some point are going to be determined as having a particular implementation type. So dates and timestamps are actually represented by a could be represented by a time underscore t value. So that's a standard Unix type. Time t is timestamp. Floating point could be represented by float or double. Integers could be represented by int values or long values. A number type could have a specific number of integer values or a specific number of 4-byte quantities that comprise it. And a varchar n is effectively a character string, but without the null terminator in the case of databases. So all we actually store are the characters that comprise the string. So if the string is JOHN, then we'd store exactly 4 bytes in the record. All right, getting to a little bit more detail about how a tuple could be implemented. Now remember that a record is a sequence of bytes and some auxiliary information that we use to interpret those bytes. A tuple is a different structure. It's an in-memory structure that we can use to extract the individual attributes from the record data. Right, so a possible struct could be the number, could start with a count for the number of fields, and since we're not likely to have 2 to the 32 fields in a table, we could use the short. In fact, we're pretty unlikely to have more than 256 fields, so in theory that could be a single byte value, but let's assume we're going to allow 10,000 attribute tuples. Then where does the data actually start? So that's an offset into the record data, and then a field descriptor for each of the fields. So this array is going to have this many elements in it, and on the next slide we'll tell you what a field descriptor looks like. And then we've got the actual data, which could be implemented by a pointer to a sequence of bytes in the buffer. Alright, so here's a possible implementation for a tuple. So we can have these kind of values. So we've got number of fields offset to the data. Now in this case, the header, if you like, or the tuple header actually contains a pointer or an offset into a page, which is where the actual record data lives. But in the header, we can say, all right, the pointer is at offset 16, it's up here. And then each of the fields, we can say where it begins in the record data and how long it is, and we could even store information about what type it is. Okay, so the second field here starts at byte 6, which is this one. Its length is 10, and it consists of chars. Now you can see that I've duplicated the lengths here. Maybe you don't need to do that. Maybe you could just store the length here and not bother with these and just have the actual byte sequence. And so that's one representation where the tuple header, the thing that describes the structure of the tuple, is separate from the actual data. And in another example, we've actually got them concatenated together. So we've got this header, and then we've attached the tuple data to it. So you can imagine that you could build this structure, have it all in memory, and then when you want to manipulate the tuple, all you've got to do is look inside here somewhere, rather than you have to go to the buffer holding the record in a page buffer. Alright, so here's the same kind of information. In this case, the starting point for the data is actually offset 16 from the start of the field. In the previous example, the 16 took us to a pointer which pointed into a buffer page, and that's where we would find this information. But now what we've decided to do is append it. So we've got this, if you like, self-contained object that the upper levels of the DBMS can manipulate. So how you do it, there's a number of different possibilities depending on whether it's a fixed size record or whether it's variable size. Okay, so that's enough discussion of tuple internals in general.